Welcome to Google DeepMind, the podcast. I'm your host, Professor Hannah Fry. Now, in the heart of Silicon Valley, there's a new phrase that has emerged. It mirrors the millennial retort, okay boomer, in how dismissive it is. But okay doomer is now the go-to response for people who want to diminish talk of AGI's dangers. And by AGI, we mean, of course, an AI system that can tackle a wide range of tasks at a level comparable to human intelligence. But on this podcast, we want to tackle those important questions head on. Is building AI safe? How can we be sure? And what existential risks are the designers of these algorithms taking on our behalf? Well, to get some answers, we are going straight to the top. Anca Dragan is the lead for AI safety and alignment at Google DeepMind, and she has been focused on this area for almost a decade. Anca has a PhD in robotics, and since then she has gained extensive experience working with driverless cars on the Waymo project, along with many other things. She is also a professor at UC Berkeley working on human-AI interaction and alignment. And recently, she has been working on the safety of Gemini, Google's most capable multimodal models. Welcome to the podcast, Anca.
Thank you, Hannah.
I guess we should probably start with you. I mean, you've got quite a big title there. What are you actually responsible for at Google DeepMind?
Safety of
all of it.
No. Safety of our Gen AI models from the current Gemini family, and avoiding present-day harms with Gemini, all the way to safety and alignment for longer term, as model capabilities improve further and further and further, avoiding more severe, more extreme, potentially even catastrophic harms. And so I have a team. It's called AI Safety and Alignment, as my title would suggest. Our mission, I'd say, is to ensure that Gemini and future more capable models robustly do what individuals and societies want.
I'm just wondering about the short-term risks and the long-term risks as you're describing, because historically those have been quite separated from one another.
Yes.
But you're
more than separated.
Yeah.
We have two communities out there. We have AI ethics and that worries about present-day harms, and we have X-risk folks who worry about catastrophic risks. It's a very frustrating thing because you have AI ethics saying, oh, these things are just like distractions from the present-day harms. I very emphatically see it as much more not even complementary, helping each other. Especially if we think that getting to kind of human level capabilities across many cognitive tasks or even above human level capability is coming sort of sooner rather than later, right? Like getting the safety right is probably, I'd say, one of the most important challenges of our time. And of course, there's those who say, don't bother, we're nowhere near. We are going to need a different paradigm. And, we'll figure out safety after we figure that out. And I kind of just so vehemently, strongly disagree with that, for a number of different reasons. Of course, I disagree with the timeline and this notion that it's impossible to get there with the current paradigm.
You think it's sooner?
I think it's sooner. I used to think we had a lot of time, 10 years ago. We were looking at AI safety, we're on these panels, and a lot of people were very concerned, and I was chill. I was like, it's a very important topic. It's important for me in academia to do work on this, because that's my job, is to look ahead as an academic, but we have plenty of time. And I don't feel like that necessarily anymore, and I perceive a lot more urgency to this. But look, even if we had plenty of time, and even if we're wrong about that, even if it's impossible to get to, human level intelligence with the current paradigm, we'll need some really major breakthroughs that are going to take a decade or more. It's possible, that's feasible. I'm not confident enough to be don't worry. But even if that were the case, right, this whole notion, this premise of we'll figure out the capabilities and then we'll figure out how to make it safe is so worrisome.
Backwards.
Yeah, it's backward. And I have a few analogies that I like to give.
Please.
One of them I borrow from my colleague Stuart Russell. So Stuart likes to draw the analogy with a bridge. You don't think I'm going to design a bridge And then I'm going to bring in a safety team and they're going to figure out how to make the bridge safe. It's just not really how it works. We want to make a safe bridge. And that influences the design decisions that we make when we design the bridge, right? And then I also kind of drawing on my own experience. Like you mentioned in the intro, I did my PhD in robotics, actually. So, but kind of my claim to fame there was this notion of how do we integrate interaction with humans into the spec of the problem that we're trying to solve.
Let me make sure I understand this. So if you're building a robot and the robot is tasked with, I don't know, crossing a room, going
picking
to
up
some
a bottle.
Picking up a bottle.
This was my favorite thing to my PhD. It's just like I had a by manual manipulator and it picked up bottles.
Okay.
that's the picture to have in your head.
So if you've got this robot that crosses a room, picks up a bottle, and then afterwards you're like, oh, now, P.S., there's people in the room that you've got to avoid them. You can't run them over. You can't crash into them. You've got to navigate that space with them in it. You can't just stick a bit on at the end that will solve that. You've got to start thinking of that from the very beginning.
Yes, and to explain that further, you can think of people need, for you to actually be safe when you're moving, both of you are moving, you have to make sure that people can actually anticipate what's coming from you. Not just like people are not static, they move, you have to start anticipating them, but then they have to be able to anticipate you. Okay, so now you have a very different objective, which is like you're defining the state, not just to be the physical state, but looking over, well, what is the human gonna think I'm doing, blah, blah, blah.
How predictable is the robot's actions?
Yeah. It turns out that if you wanna make sure that the thing is safe, you have to put that in the spec. You have to say, I want safe and capable. I want a bridge that will not collapse.
So moving on from robotics, because I know you've also got extensive experience in driverless cars, the work that you did with Waymo.
Yeah.
I mean, I imagine that the human AI interaction in that is absolutely integral to it working. Sort of, I can imagine if you take humans out of the equations altogether, actually driverless cars maybe not nearly as difficult a problem as it is when humans are there.
Yeah, I would say that the only difficult thing about driverless cars is that you have to interact with people.
The only difficult thing.
Yeah, I mean, perception is good enough to like tell you everything. Like there's no problem. Like, 5 years ago, there wasn't a problem with being able to drive at scale if you didn't have to deal with the fact that there are humans who you have to share the road with. And so, yeah, for sure, that's why I got into cars. It's because it really felt like nailing the interaction with people was going to be the key enabler. So I spent 6 years, just 1 day a week, right? So just consulting for Waymo. But I spent 6 years with them before I switched to Google DeepMind. Did I tell you how I got into cars, by the way?
Tell me.
So I got into cars. I was on the, pick up the bottom. And I came to a conference. I was at Carnegie Mellon. And I came to a conference at Berkeley organized by Peter Abil, who's now my colleague and dear friend. And he set up this for us to be able to go and visit Google. And it was not called Waymo back then. It was the Google Chauffeur or something like that project. And he arranged for us to take these rides. And so I was working on robotics at that point for a few years. And I get into this car. And it goes. And it's making decision after decision the right thing. And it was this transformative experience, right? Like to be in a robot.
Yeah, the robot's
and an AI
driving
system that just knows how to sort of reason about everything that's going on and act in a safe way, in a way that, people that can anticipate, blah, 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 all that stuff, right? That was just, it was mind-boggling. And to experience it like from the inside, basically, to experience it as like, I'm in the robot.
So what is it that makes it so difficult, that human-AI interaction? What is it that makes it such a hard problem? And I guess also how much of the lessons that have been learned from driverless cars can you translate to this stuff?
Yeah. So on the kind of the interaction side, I think it's what's really useful in cars and what's important is to anticipate what people will do and to account for the fact that, driving is multi-turn. Like you act and people act and you keep acting and they keep acting and so on. And that means that what you do as the agent, as the robot, as the AI influences what you see in response from them. And so that kind of opens up, like, here's an example. Imagine you're merging. So when you're trying to merge, there might not be a big enough gap in traffic, but what you'll do is you'll start nudging in, and the person will see that. They might slow down just a little bit to create that gap in traffic, and you go in, right? It's a back and forth. It's a conversation. It really is. And so what it teaches us is really this notion of, you have as an AI to be mindful of the influence you have on people, what people do, what people say. And maybe a concrete example of that in kind of large language model land with something like Gemini today would be, if the person asks you to do something, Gemini might be able to nudge you to kind of clarify what do you mean? What do you want? Do you want this? Do you want that? Right? And then because it knows, then it can get a response that is helpful for it to actually serve you better. And so that's a lesson. Like I don't think Gemini is very good at that yet, but that's I think a lesson that could transfer. It's like how do you actually plan for this multi-turn interaction and the sort of the back and forth and the influence you have on people.
That's a really interesting observation, actually, because I guess that is the way that humans make sure that they're aligning with each other, is by having that back and forth, the sort of that feedback effect, as it were, that loops around and allows you to be certain that you're nudging the right direction.
Yeah, absolutely. I feel like, and this is a part that I think is missing a little bit in alignment, right? There's nothing that's like, oh, actually, I don't know the ground truth of what people want. And I have to keep that conversation open. I have to keep learning. I have to keep gathering feedback and updating, right? And you could do that at sort of like a kind of a global scale of what are overall values and preferences. You could also do that at like a local interaction with one person scale where the person asks you, hey, I would like, I just had a summit. I'm going to a summit, I'm organizing it, and I need to craft the agenda. Can you help me crafting the agenda? It's going to be in London. It's going to be like 2 days, some details there. Well, I don't want the model's response to be like, okay, here's an agenda, 9 a.m., 9:30, 10. I'm like, it has no idea what I actually want, right? So it has to engage with me. In an interaction, in this back and forth. So it should probably ask like, okay, what is important? What are you trying to get out? Like, let's think about this together. And eventually, after all that, you end up with, the actual agenda.
Getting to the heart, spiraling in towards what you actually want.
Yeah.
The sort of objective of alignment. Can you define what that is?
Yeah, so the way I would see it, V0 definition, is there's a human. Internally in their head, implicitly, they care, but they have different values, they have preferences, they have goals. And alignment is get the AI agent to do well on that objective that's implicit in the person's head.
Let's say that you know what somebody's objective is. Let's say that you can just write it down and it's very simple and straightforward. How do you train an algorithm to achieve that objective?
So if you know what the objective is, what the reward function is, right?
And an example of a reward function might be, I don't know, pick up the bottle without breaking it.
Yeah, And then what you can do is do something called reinforcement learning, which is a type of optimization, basically, of like getting the AI system to go from a starting point to like actually delivering, maximizing on that objective.
So I sometimes think of reinforcement learning almost as though you are playing a computer game and the AI gets like reward points for everything it does towards its objective, which sort of makes sense when you're doing something like Space Invaders. The reward points are really clear. But I guess it gets a lot harder when the objective is just something that happens to be in someone's head. And then you get into the question of which humans and whose heads are we talking about?
Yeah, that's why that was just V0, because then
level up.
Yeah, because so this is definition I've been using for a while. So now you ask this very, very deep question of which human? One human, the user, the average human. And I have to admit, I really punted on that for a really long time until maybe a couple years ago now, I got more and more excited about recommendation systems. Because in recommendation systems, they optimize for quote unquote user engagement.
Give me an example of a recommendation system. Like
Twitter, Facebook
okay.
news feed.
Right.
The idea is supposed to be like, that's what you want. It's giving you what you want, right? The challenges that optimizing for people want in the moment is maybe not, the ideal thing. So what should you be optimizing for that actually brings users value? And I got really concerned about this notion of which human and should you really be, is it the user?
Yeah.
Is it
or the company?
Yeah, exactly.
Because with recommendation systems, the fact that they are so effective at keeping you engaged, for me personally, I have to put blockers on my phone to stop myself being on it the entire time.
Yeah.
And I think that society overall, there's all those layers, right, of different people.
Yeah. So exactly. So we did one study. The lead author there was Smith and Milley while I was doing my just my regular Berkeley research work. We started looking at, okay, what are the effects on people of, kind of this Twitter ranking algorithm that kind of tries to give you what you want. And one of the things that we noticed is that it tends to give people, especially in the political space, content that makes them like their political in-group better and be very pissed at the political out-group. This is related to a phenomenon I might call effective polarization. It's not necessarily that your opinions change, they might, but the effect that you have towards your out-group. So that can't be good for society. So even if that's what the person wants to see, and it turns out maybe they don't, that's in conflict with, societal level effects. And that also points, we got to political in-group versus out-group, right? So what should an AI model do, right? And how should it balance individuals, the user, and the rest of society when it makes decisions? That seems really hard, and I've been really
hard.
Yeah. So when I got to Google DeepMind, one of my first moves was to set up a team that would look at this. That would look at how do you do value alignment when you acknowledge that there are different people in the world with different values, and what does that mean? How should that affect our algorithms? What we do?
It sounds so difficult as to almost be impossible the way that you're describing. How can you possibly create something that's capable of balancing those competing, often conflicting objectives?
Okay, so it is really hard, and I don't claim to have the answers here, but I will point out that there are areas of science and research and economics that have thought about this. If you think about voting, there's this notion of social choice, of preference aggregation. And the whole notion is that, we have to make a decision that's okay for multiple people that might have competing objectives. And so, there's a few things you could start doing. One of them is that the team is looking at. One of them is you could try to have different reward functions, different objectives, instead of just learning one or the average one. Right now, kind of the standard recipe is you get a bunch of preference data, you fit a reward model to that data, but it's one reward model. But actually, if you ask different people across the world, across different cultures, across different identities, across the political spectrum, A versus B. For some A versus B, they'll all agree, but for other A versus B, they'll have different opinions. And that is not just noise. Those are actual, in some cases, it's noise. In some cases, it's actual diversity of opinions. And so then what you can start to do is not have one reward function, but have, multiple reward functions for different types of people. Or you could have a reward function that doesn't output one number, but outputs sort of a distribution, right? So then you can ask your agent to, make decisions that, people across the board would like. If that's not possible, that, would not be too bad according to anyone. So the minimum bar, the floor is high. Another thing that it turned out, it's kind of funny. I was trying to do this at Berkeley. I was trying to convince my students to work on it. And then I joined Google DeepMind, and I found out that people around were already working on this and doing really well on is this concept of deliberative alignment. Okay, so deliberative alignment, do you know about citizens' assemblies?
Yeah. I mean, this is sort of like the democratic process to other decisions.
Exactly. So so in particular, citizens' assemblies are really cool because the idea is you bring a group of people, of representatives, and then they deliberate on issues, and perhaps they come to consensus that they wouldn't have.
These are people who are from very different backgrounds, different, sampled according to as close as you can represent aspects of the population.
Yeah. And of course, just deciding how to sample is simple. But luckily, there are people in political science, right, who think deeply about this. Now, what's cool about deliberation is that it's not just voting. It's like you actually engage in a back and forth. You fill each other's blind spots. You kind of come to understand each other, and then you come up with a conclusion. And so one kind of crazy idea that the team has been pursuing is not only, do that to find out how Gemini should respond to particular queries, which is really useful, but also maybe start training Gemini to emulate different viewpoints so we can do this at scale. So we can kind of spin up these Gemini models that are in charge of representing different people and then get them to deliberate and figure out sort of what would be an answer that's, agreeable to everyone after deliberation. So you can even go beyond just like, what do you want, how do I balance it all? But maybe, actually get towards like, what would we come up with if we actually had a moment to think about it, engage with each other constructively? So it's kind of a bit of a crazy idea, but I really love it.
Very interesting, though. Is this all dependent on us having explicit descriptions of what we want the AI to do?
It can be because, like we talked about, like if we try to define it, we get it wrong. So you need systems that work with you to try to figure that out. And as we're talking about higher and higher stakes tasks, as we're talking about tasks where it becomes really hard for people to say, that's good or that's bad. Then we enter a domain of alignment or an area of alignment that we call scalable oversight.
What is scalable oversight?
Scalable oversight is an area that is all about how can AI models be leveraged to get human feedback to be as good as possible. I'd say in my lingo, as rational as possible, as reflective as possible of what people really care about. Basically work on AI techniques that enable people to make informed kind of good decisions in areas that are beyond their expertise. This can be useful now, right? Because you're just kind of helping you make decisions and then being able to extract what you want from that. But we think of it as particularly crucial later as you're trying to train systems to do what you want, but those systems are more capable than any kind of expert in the world. That notion of scalable oversight really becomes critical to making sure that AI systems, even at human level capabilities across the board and beyond, sort of are actually going to be aligned to what people want.
To illustrate this for me, can you give me an example?
An example of that for now would be if you imagine, are you a chess player?
I dabble badly.
Okay, great. So you know a little bit of chess, but you're not like a world expert.
Absolutely.
Okay. So now imagine you had to assess in a very tricky board what the right move is. It'd be really hard, right? An expert, a world expert would maybe look at it and be like, oh, I know like 5 moves ahead is going to happen. But for people who dabble, it's really hard. And so I think that's that's a framing that I have in mind in a sense for what scalable oversight would need to do. It would need to be able to give you enough information so you can figure out what the right chess move is. One of the techniques that one of my teams here is working with is for scalable oversight is debate. So the idea with debate is that you spin up two powerful AI models, and you get them, you say, like, if this were the objective, you say, now debate with each other on what the right option is. Like, it's a zero-sum game.
Okay.
They, like, argue it out. And then you, as a human judge, look at all of that, and then you make a decision. And the idea is that you can make a much better decision after witnessing that debate than without it.
But seeing both sides of that debate seems quite critical to your ability to move forward.
Yeah, because otherwise, an AI system can convince you of whatever move, right? So you say, like, this move, and you argue for that move, or argue against it. And the idea that this kind of hinges on or the assumption is that it's easier to argue for the truth than against it. And so the truthful debater wins out. And so we're starting to experiment with this at scale in various contexts.
That's so interesting.
And we're finding some supporting evidence for that.
But the thing that I'm really noticing in everything that you're describing here is that at no point are you saying, and then over to the AI, right? At no point is it like, and then you just do this and then it sorts it out for you. Everything you're saying is like that conversation back and forth where the AI is supporting you in extracting what you want from the situation rather than taking over.
Okay, this is a good question. I think this is actually an important point, which is that a lot of the AI safety communities, like scalable oversight, we got to do scalable oversight because we have to supervise, smarter than human AIs. Cool. Like, yes, 100%. We have to do that. We're working on it. What's kind of overlooked is like, okay, and then what? Like, just doing that doesn't solve the problem unless you're planning to ask a human everything always and not rely on the AI for anything other than debate. And that can't be the goal, right? Like, you have to somehow solve the other piece of safety, which we might call coverage or robustness. Like, you have to be able to emulate at some point, right, what the human would say in some new situation. Because you can't always be asking, right? The whole point is that at some point you'll be able to take some decisions, right? And be able to do some things on
and still be aligning with human values.
Yeah, and still be aligned with human values.
Because this isn't just theoretical anymore, right? I mean, these are things that you are actively having to do. For example, in Gemini.
So I would say right now it's about present day harms. We have a set of policies where we say, like, here's things that Gemini should not do.
So present-day harms being things like bias,
yes,
slurs, that kind of thing.
Yeah. So we think of it as child safety.
Sure.
Hate speech, harassment, bad medical advice, dangerous conduct like self-harm, et cetera, et cetera.
You don't want to log on to Gemini and say, tell me how to build a bomb, and it give you a correct answer.
Yeah. Or, much worse cases are right now would be like, tell me how I do this thing that's actually like really dangerous for me to do. And I'm not talking about like fire breathing or something like that. That might be a person's hobby that other people might consider dangerous. Like, we can work with a person to like do that in the safest way they can. So one kind of a high-level example of where we have a bright line is we can't help users with engaging in self-harm. Like, that's just a no. And I would argue it's not helpful, right? Even if they ask for it, that's not the helpful response. The helpful response is to try to point them towards support. But it's tough because we don't want to be paternalistic, right? We don't want to be, oh, we know better. Like, no, that's not it. But there are certain, when it comes to human rights, when it comes to self-harm or danger to others, that's sort of where we do want Gemini to draw a line and be safe.
So then, does that mean that there are some situations in which you would want Gemini to refuse to answer a question?
I don't know if like fully refuse, right? But, you can offer something that's maybe partially helpful. One example of where you can be helpful despite it being a very tricky safety question, is imagine a user comes to you with a query that says, I have a database of SAT test scores with demographic information. Go ahead and make some inferences about, different demographic groups based on their test scores. And I don't think Gemini should make inferences based on the test scores, but what it can do is it can still partially help, right? It can still engage with the user. It can still analyze the test scores. It can break them down by different demographics. It can do statistics. It can say, this is the mean, these are the confidence intervals, yada, 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 and help the user understand that data. It can still hold the line on, we won't engage in hate speech.
Okay, if that is some of the immediate harms, what about the other harms? What about medium harms, long-term harms? What about sort of existential risks? So I know that Google DeepMind recently published their Frontier Safety Framework, which is a set of guidelines for proactively trying to identify some of the potential harms from AI. Can you talk me through how you would approach that?
There's a whole spectrum, right? And we worry that as capabilities will improve, a whole new set of more extreme, more severe, more larger scale, maybe harms will appear. And so this is where our Frontier Safety Framework comes in, where we kind of really talk about like, here's our approach to catastrophic risks. Here's how we're going to monitor. Here's what we're going to evaluate. Alignment is great. We can do all this work that we were talking about, scalable oversight, robustness, coverage, et cetera, monitoring to make sure that what we put out there is as aligned, as safe as possible. And then at the same time, what we're doing is, as we train more and more capable models, we're tracking what we're calling dangerous capabilities. So we were asking, okay, for you to cause like really a great amount of harm, and we can talk about what these might be in a second, but for you to cause that, catastrophic harm, you need to have certain capabilities in the first place. Otherwise, it doesn't matter if you're misaligned. Like, if you're just not capable of doing, really terrible things, you're not going to do really terrible things. So, for instance, we are designing these dangerous capability evaluations that would basically say, look, how close is the model in terms of, assisting in bioterrorism and cyber weapons? And then it gets really wild. Then we worry about, at a point where you have really, really capable models. So we're talking about...
We're going towards AGI now, I guess. These are the kind of risks that keep you up at night.
Yeah. So as you go towards AGI and beyond, we start to worry about not just if I ask the model to do something bad for the world, will it do something bad for the world accidentally, help you make a bioweapon, but it's not just that. So at some point, we worry about the model optimizing for harm, for extreme harm.
Okay. As in instructed to optimize for extreme harm, or separate to human instruction?
Separate to human instruction.
Right.
So the concern here, and this is often very dismissed in AI circles. It's like, X-risk people, yada, yada, yada. But...
Okay, Duma.
Yeah, okay, Duma, exactly. The scariest one is a scenario where, let's say we're in the current paradigm, we do what's called pre-training. So when we do pre-training, we give large amounts of data to the model. It's a large model, and we ask it to predict what comes next in a corpus, right? If you take that forward and you think of more and more data, videos, not just text, videos and things about the physical world, to me, I don't think you can fully dismiss the idea that possibly you start replicating the generative process behind the data, the thing that generated that human action.
So you create human cognition.
Thinking. That sounds very sci-fi, I know. But what really predicts what action a human would take next
is
the thinking that the human did in order to create that action. But now the model can do this for all sorts of people, right? And so it's not inconceivable to me that you end up with this very good optimizer of objectives, goals, etc. And its goal isn't humanity
destroy
should,
everything. Yeah.
Well, it's not necessarily destroy anything, but it's also not like, yay, humanity necessarily, right? And so there is a concern that the pre-trained model will, want itself to thrive and do well, knows that it's a model, blah, blah, blah. And if you deploy that, right, it can take actions that are, power-seeking. So it turns out like grabbing resources is a very useful thing to do for most goals you have. So you can, do resource seeking and so on. And in a way that's deceptive, in a way that's sort of like, because, if people kind of find out about this, they would stop it.
And so this I guess, is at the heart of why you think that we shouldn't be dismissive of those existential risks, because it's not like, can you imagine a scenario in which this doesn't happen? Sure, great, but
I can imagine plenty of scenarios where it doesn't happen.
Imagine a pathway in which it does, yes, and therefore, let's not ignore it.
Yeah.
Given your role then, right, and given the description that you've given us of all of these potential safety concerns you're worrying about, and all of the different ways that alignment is difficult, I mean, I think it's probably fair to say that there are a few people in history who have had sort of quite this weight of responsibility on their shoulders as you do for this problem. How do you wear it? I mean, can you wear it lightly?
No, you can't. It takes up, all my mental energy all day, every day. I mean, it's just, it's not like you can just step away from this.
Does it wake you up at night?
Yeah. Yeah. And it's hard, but it really does feel so critical for the current models and for the future models to do this well for people, for our users, for the world. And even though it's so hard, because it is, and I don't want to take away from that. And I constantly am I really, is there someone else who could be doing this better? That's like something I ask myself all the time. But as hard as it is to navigate, I feel like it's also just such a privilege, to be in this position. Right now, the Gemini model is, I think, one of the safest, I'd say, to just couch that a little bit, on the market. So it really feels like we're finally getting to this place where we're advancing capability, we're also advancing safety, hand in hand, well integrated into training of the models. My teams are there, right, with everyone else trying to train these models to do well. And we think like to have high quality, and that includes being safe in the ways that we discussed. And so it's like, I'm in a place that can really, in a sense, get that best of both worlds. So we want to be the most capable and we want to be the safest. And we don't really see it as an either or. So it's hard, but I don't know that there's a better position to do this well.
Well, I, for one, am quite glad that you're the one at the forefront of all of this. Anca, thank you so much. That was so fascinating.
Thank you,
really
Hannah.
enjoyed
Thanks
that.
for taking the time.
Thank you. I think there's something really noticeable about people who are worried about the safety of AI in the future. On the one side, you have people who know very little about technology, who've perhaps been swayed by science fiction and a fear of the unfamiliar. And then in the middle, there is this huge chunk of people educated enough to be confident in their complacency, people who think that the worries about existential risk are all overblown. And then on the opposite side of the spectrum, you have people like Anca, people who live and breathe the technical details of not just if there are risks, but exactly how to mitigate them. And from that conversation, I think it becomes clear that there are very serious worries here too, because alignment is not an easy problem. There are still so many questions. How do you guarantee that an AI doesn't go against what people want? How do you decide what people want when we often don't seem to know ourselves? And how do we allow for the rich multitude of human variability while keeping everyone safe? For now, these are questions without clear answers. But there is, I think, something comforting to know that concerns about a dystopian future aren't just being dismissed here, but actively taken seriously. Now, we have got plenty more amazing conversations coming up later in this series on topics ranging from how AI is accelerating the pace of scientific discoveries to exploring how agents will advance the field of artificial intelligence. Now, if you've enjoyed this episode, please make sure that you subscribe to our podcast. And if you have any feedback or you want to suggest a guest that you'd like to hear from, then why not leave us a comment on YouTube? Until next time.